Hi, I'm Dr. Steve Rehse. I'm a professor in the Department of Physics at the University of Windsor, and today I'd like to talk about a medical procedure that uses some really interesting physics. In medical physics, we call this selective photothermolysis, but you may be more familiar with it as laser hair removal or laser tattoo removal. Now the photo in photothermolysis just refers to a laser, and a laser is a very special kind of light. It's not only a very, very bright light, it's a very powerful source of light. And in fact, it's so powerful that when we shine the laser down onto the skin, that heat that it creates has nowhere to go. And so it's actually going to cause all the cells to boil and then explode. And if the target of that boiling is the hair follicle, that hair will never regrow. And in the same way, if you focus the light down onto the ink that's embedded in the skin in a tattoo, that ink will then explode, then the body will flush it away, and the tattoo will fade. So today we're going to demonstrate this idea using a laser that looks like this. Now, this is not the type of laser that they're actually going to use in that actual procedure. Those lasers are going to be much more intense and they're going to be flashing many times a second. The light may or may not even be visible to the naked eye. However, this will demonstrate the principle really, really well. To do this, we're going to also be using some balloons that I've blown up to simulate the hair follicle. Now, before we start this, we're going to have to put on our laser safety goggles. During this type of procedure, the operator and the patient always have to wear special eye protection because this laser light is very, very dangerous to the eye. So again, this is something you're not going to want to try at home. So, we can demonstrate this by turning on the laser, and let's just see what happens to our simulated hair follicle. So, you can see that that actually works really, really well. However, if that's all there was to this procedure, that really wouldn't be very useful, because all that heat would be absorbed into your skin, it would be extremely painful, and would probably lead to permanent scarring. The key to this is that we choose the color of the laser light to be just right. That's the selective part of the procedure. If we can select our color just right, the dark hair follicle or the dark ink of the tattoo will absorb all that light, but the skin that it's embedded in will be completely transparent. And so all you're going to do is target that follicle or the ink, and there will be no damage to the surrounding tissue. So to demonstrate that, what I've done here is I've embedded some of these simulated hair follicles inside a transparent balloon that's going to represent the skin. So if we've done everything just right, when I shine the laser into this, I'll be able to explode the follicle inside and completely not damage the skin around it. So let's see if that works. So there we have it, selective photothermolysis. The ability to choose the color of the laser to preferentially target tissues inside the skin is what makes the laser so useful and one of the most modern, important tools in modern medicine. Thank you.